please, let's start by working on the first one, which says there is this airplane that is flying towards a radar station at a constant height of 6 kilometers above the ground. If the distance S between the airplane and the radar station is decreasing at a rate of 400 kilometers per hour, when S is 10 kilometers, what is the horizontal speed of this plane? All right, let me repeat. We say an airplane is flying towards a radar station at a constant height of 6 kilometers above the ground. If the distance S between the airplane and the radar station is decreasing at a rate of 400 kilometers per hour, when S, which is distance, is equals to 10 kilometers, what is the horizontal speed of the plane? Let's work this together, but from your side, okay? I need you to tell me what is it that you know from this given information, and what is it that they need us to calculate. Once you can be able to identify the information that is given to us, as well as what they need us to calculate, then you will be able to find what is required. So I'll confirm or help you where you are actually not finding what is actually required, since we are together here. Okay?
Okay, sir.
Yes. Should I enlarge this screen, or is it okay? Are you able to see?
I've zoomed in on my phone.
Oh,
So I can read it. I don't think I'll mistake the values that I'm seeing.
okay.
I'm just trying to draw a picture here so I can also put down what we've been given.
Okay. Yeah, you can draw that diagram. I'll keep quiet. Then we'll discuss what is it that you'll be having on the diagram before we continue.
So I have the airplane drawn, and then I have the radio station that's 6 kilometers away from it. Well, 6 kilometers above the ground. Then between the airplane's position and where the radio station is, they told us at 10 kilometers from the radio station, it's traveling at 400 kilometers per hour. And they tell us that's the rate at which the distance between the airplane and the radio station is decreasing. So from the fact that they're saying that this is a rate, I'm assuming that then we're working with the derivative, or the answer for the derivative is that 400 kilometers per hour. But now they're asking us for the horizontal speed of the plane.
Yes.
So,
Okay. Yes, I'm listening. Let me keep quiet. Let me give you an
I think
opportunity.
this one, I don't think I was here for the previous sessions on this. I just caught the tail end of it because I remember guys were going through the questions, and then it was like these word problems, and then I wasn't really seeing, or I was struggling to get to the point where the other students were figuring out how to solve the question. So from the information given, figuring out what they needed to do with the information that they were given to manipulate and create the formulas they needed to solve for the answer. In this case, that's all I've like identified. In terms of how we would go about to calculate the horizontal speed, I'm not sure how we do that.
Okay. Don't worry. We are together here. Let's look at it in this way. Please draw a triangle. A triangle, let's say, are you left-handed or right-handed?
Right-handed?
Yeah, you and I are right-handed. Please draw a triangle in such a way that you see, when we draw a right angle triangle,
Yes, sir.
please draw this triangle in such a way that that right angle will be on the right-hand side.
Okay. So is it kind of, what do you mean on the, so if let's say I have a square, ne, and I divide it diagonally from the left lower corner to the right top corner,
Oh,
and then thinking
let's
about
say
the triangle at the bottom, is that what you mean?
from you said if you have got a what? A square.
Yes, sir. And then
Yes, you made it easier for me. Yes. Now,
okay, so I've drawn the
now
triangle.
you draw. Yeah, it's a rectangle. Then you draw a line from the from the top right corner to the bottom left corner in such a way that you've got two triangles in this rectangle, ne?
Yes, sir.
Yes. So now, do you see this? Is not a right angle triangle, but you see this right angle
Yes, sir.
at the bottom.
Yes, sir.
All right. You and I, please, let's look at, now you drew it within, these two triangles are in a rectangle. Now, please, our focus should be on the lower triangle.
Yes, sir.
Meaning in this case, we are not having the top
triangle.
triangle. Yes. Do you get me?
Yes, sir.
That's how then this problem can schematically be drawn. I mean, schematically be represented. Now, you and I, let's go again to this question. It says, an airplane is flying towards a radar station, meaning this plane is up in the sky, yeah? Then it's approaching where it's going to land, okay?
Yes, sir.
Obviously, from the top going down, yeah? So, do you see this line that
Is it
divides?
landing? Is it landing? Is it landing at the radio station?
At the radar station. Yes.
Oh, I I thought it was okay, so maybe you do need to increase it because I read it as like radio station. So I was confused how we were gonna because I had thought of a triangle, but I was like thinking, no, that's not it's not gonna help answer the question of the horizontal distance because we don't have a diagonal direction of movement. So is it
How
that
is it? How is it now?
you could increase it more, sir, if possible, and then just move over to the right. Yeah, that's better, sir.
Is it?
Yes, sir.
Okay. Because is it clear now from where you are?
Yes, sir.
Okay. It says an airplane. This plane is in the sky and then it's approaching that radar station. We can probably say is an airport where it's going to land. Okay.
Okay.
Hmm.
So it makes a lot more sense now. Because then we have the height at which it's starting, that's 6 kilometers above the ground. We have the 10 kilometers it is from its landing point. And then if it's on a downward descent, or we can calculate the hypotenuse. But then now it's about answering the question, which is what is its horizontal speed, right? But if
Yes.
we want to calculate horizontal speed, doesn't it need to be moving horizontally?
The horizontal
Yeah.
speed. Okay.
Yes, sir.
Lerato, this
Yes,
is
sir.
not witchcraft. Okay.
Okay,
The-
sir.
yes, I agree with you to say the height. Here is this plane. You and I are at the airport. We are waiting, or maybe from where we are standing, we are able to see that plane. From a distance, we are able to see that plane that is going to land at the airport. Okay.
Yes, sir.
We are watching it. And then we do see that, as they are saying, an airplane is flying towards a radar station. You and I, let's consider this radio station to be an airport where it's going to land. Okay.
Okay, sir.
But where we are seeing it at a constant height of 6 kilometers above the ground, that is the height, that is how high the plane is from the ground. Okay. You
Sir.
and I agree that that 6 kilometers above the ground is the height and is the y, according to this diagram that we drew. Okay.
Yes, sir.
Our y is 6. Do we agree?
Yes, sir.
Then that is what we get from the first line. From the first line, we do know that this plane is going to land. It's not taking off, but is going to land. The height is 6 kilometers above the ground. From the next line, so we are able to tell that y is equals to 6 from this line, and this plane is coming down to land. Next line, if the distance s between the airplane and the radar station is decreasing at a rate of 400 kilometers per hour. All right. Now, if the distance, remember, the distance is getting shorter and shorter as the plane approaches the airport where it's going to land. Do we agree?
Yes, sir.
Because it's going to land. It is not going away from the airport. It's going to land at the airport. So that means the distance is getting short. Distance is kilometers and time. They're saying if the distance s between the airplane and the radar station is decreasing at a rate of 400 kilometers per hour, Now, let's talk Lerato. From the triangle that we drew, we agreed that y is equals to 6, is that height, okay?
Yes, sir.
Then we know side of the hypotenuse to be s, is the distance from the top to the ground, from where the plane is, okay?
So what did you say about S?
S, look at S in this way. What should I say? You see at the edge, you see this triangle that we drew, né?
Yes, sir.
At the top, at the corner of the corner of the hypotenuse and the y. All right.
Yes, sir.
Let's say is where the plane is. We are seeing it. That is our reference point from where we are seeing the plane. You and I. Okay.
Okay.
Because from the ground to that line of the hypotenuse and the y, they meet. Remember, this is forming a triangle.
Yes, sir.
This is what I'm saying. This line of the hypotenuse is meeting the y line, okay? The y value line.
Yes, sir.
Then at the top there is where our plane is. Do you agree? Sir. Because from that corner down to where the x-axis meet the y-axis, the distance is y, and then it's 6 kilometers. Do we agree?
Yes, sir.
So the plane is at the top there, where the hypotenuse meets the y-axis. Do we agree?
Yes, sir.
Now, there at the corner, we have got this plane. The hypotenuse is the distance, is the s. We can denote it by s. We know that from the ground to where the hypotenuse and the y value meet, at the top is where the plane is.
Yes, sir.
Because it's 6 kilometers above the ground. Therefore, this line below is what we are referring to as the x, the horizontal. Do we agree?
Yes, sir.
Is it making sense?
Yes, sir.
Okay. Now, if that is the case, you and I are now saying, you mentioned a crucial aspect of handling these related rates. Yes, we are dealing with derivatives. But now, first of all, let's complete or let's agree on what we are having, let's say diagrammatically, before we can start to talk about any other thing. We agree that the hypotenuse is S,
Yes, sir.
and the y value on the y, this line of y is the distance from the ground to the plane.
Yes, sir.
So S on that line of the hypotenuse, we can just write S. On the y line, we can just write y. And then the line below is the x-axis. We can just write x. Are we together?
Yes, sir.
All right. Now, if we agree, now let's move slowly. You and I are, okay. Now go into the next line. If the distance if the distance s between the airplane and the radar is decreasing at a rate of 400 kilometers per hour. Now, we said, if the distance s, these people are also guiding us here. If the distance what? S, meaning we represent the distance by what? by S between the airplane and the radar station is decreasing at a rate of 400 kilometers per hour when S is 10 kilometers. I pause there before the comma. Now, please, let's talk. You and I agree that y is equals to 6, eh?
Yes, sir.
And then y equals to 6. Now, the distance is decreasing. That distance, which is S, is decreasing.
Yes, sir.
Is the distance as well as the time, which is measured per hour in this case, okay?
Yes, sir.
This distance is S, okay? Now, in terms of the derivative, okay? S is equals to distance. But this distance is decreasing at 400 kilometers per hour. Okay, let me take you a few seconds back. Please write, you and I agreed that y equals to 6, eh?
Yes, sir.
Now, let's differentiate this y with respect to time. This will be dy over dt with respect to time. Eh? What will we get? We say y equals to 6. Therefore, differentiate y. We write y is equals to 6. Therefore, dy over dt, what is it equals to, Lerato? The derivative of this 6, what is it?
dy over dt. So won't it be 0?
Dy over dt is going to be 0. We agree because 6 is remember the derivative of a constant is 0.
0.
Yes. So we agree that dy by dt is equals to 0. Ne?
Yes, sir.
All right. Now, another piece of information that we know. We know that distance is given by S, as they've said in this case, distance S. Now, this distance is changing with time. Remember, as this airplane is moving, the time is not constant. Do we agree?
Yes, sir.
The time is also changing. So now, as we are told here that when it is, we'll come still on the next line, but we know that S is 10. On that one, we agree, okay? 10 kilometers.
S is 10 kilometers.
S is 10 kilometers. We agree on that one, eh?
Not that X is 10 kilometers. So it's not X that's 10 kilometers.
Okay. Slowly like this. Lerato, please look at that diagram. Focusing on the lower triangle. We said the plane is at that corner where S meets the Y.
Yes, sir.
Now, what is this S? This S is the hypotenuse, eh?
So I thought the second sentence where it says the distance S between the airplane and the radar station is decreasing. I thought that distance of S was referring to, like, I understand when you said that we're calling S the hypotenuse because it's descending, it's approaching the radar station diagonally. But when I read it in the question, I thought that S was referring to the x-axis's distance. Which is why,
Uh,
again, I think now I was confused by the question of them asking, what is the horizontal speed? So that S, like you've been saying, is referring to the distance of the plane descending.
S, yes. S is referring to that distance. Okay, maybe let me clarify something here. You and I are agreeing on two aspects. That S is the distance from where the plane is to where it is going to land. That's S.
Yes, sir.
And then Y is the height, which you and I agree that it is what?
6.
It is 6 kilometers. Now, they're saying if the distance S between the airplane and the radar station is decreasing at a rate of 400 kilometers per hour, I agree with you that that S is the distance. You and I agree on that one. And I'm not changing, okay? But this is the rate at which here we are taking distance and time together. They are saying if the distance between the airplane and the radar station, distance between the airplane and the radar station is decreasing at a rate of 400 kilometers per hour when S is 10 kilometers. That's why I said, let's pause there. Okay. Let me take it easy. This thing is not difficult, Lerato. You and I agree that y is 6, and then the derivative, the dy by dt, dy over dt, the derivative of this y equals to 0. dy by dt is 0. Do we agree?
Yes, sir.
S is equals to 10. Do we agree?
Yes, sir.
And S is our hypotenuse. Do we agree?
Yes, sir.
Good. Now you and I are agreeing on something again. Now, if the distance S between the airplane and the radar station is decreasing at a rate of 400 kilometers per hour. What is 400 kilometers per hour? Now, that distance is getting shorter. That distance is getting shorter as the time is getting shorter for this plane to approach the radar station. So now, can you and I agree that ds over dt is equals to minus 400 kilometers per hour? Because this distance is decreasing.
Yes, sir.
Do you see it?
So it makes sense why you're saying it's negative, because obviously the distance is becoming smaller.
Because this plane is going to land. It's going to end up being at 0. When it lands, when it comes to a complete standstill, the distance will be 0 between the plane and where it's going to land. Do we agree?
Yes, sir.
That's why I'm saying, can you and I agree that ds over dt is equals to minus 400 kilometers per hour?
Yes, sir.
Now, you and I, if we agree, now, these people are looking for, okay, then we are told that S is 10 kilometers. We agree, ne?
Yes, sir.
On S. You and I are agreeing on something important up to so far. you and I are agreeing on the y, which is what, Lerato?
6 kilometers.
You and I are agreeing on s, which is the hypotenuse. Do we agree?
Yes, sir.
Which is what?
10 kilometers.
10 kilometers. Do you remember that theorem of, before I go there, we'll get to that. Now, we agreed that ds over dt is equals to minus 400 kilometers per hour. We agreed, né?
Yes, sir.
We know that s is equals to 10 kilometers. That's the distance. Now, after the comma, in the second line, they say, what is the horizontal speed of the plane? Okay, just take a guess of what is it that they are looking for here.
They're probably looking for x, sir. Or the derivative of x. I'm not sure.
Yes, the rate at which x is changing with respect to time. They are looking for dx over dt. That is the horizontal speed. Do we agree?
Yes, sir.
Now, you and I agree further that these people are looking for dx over dt. Do you see it?
Yes, sir.
All right. Now, going back to that triangle of ours, remember we said s is equals to 10, né? S, the hypotenuse, is the distance between that airplane and then where it's going to land, that radar station. S is 10. Do we agree?
Yes, sir.
And then Y, which is the height of the plane, is 6. Do we agree?
Yes, sir.
Okay. Now, let me repeat. You and I agree that dy over dt is 0 because y is 6. Therefore, dy over dt is 0. And then you and I agree that ds over dt is equals to minus 400 kilometers per hour. And then you and I agree that these people are looking for dx over dt.
Yes, sir.
Agreed, yes. Now, remember the theorem of Pythagoras.
Yes, sir.
What is it?
Hypotenuse squared is equal to the y squared plus x squared.
Okay. Please write it down. After writing it down, please let me know.
I've written it down, sir.
All right. From that equation, do you agree that the hypotenuse is 10 squared?
Yes, sir.
The y, do you agree that is 6 squared?
Yes, sir.
From there, please calculate x and tell me what you get.
I got 8, sir.
You got 8. Thank you. Now, you and I are getting somewhere. We agree that x is 8, eh?
Yes, sir.
Okay. Now, we have got x squared plus y squared equals to s squared. All right?
S squared plus y squared?
X squared, x.
Yes, sir.
From the theorem of Pythagoras.
Oh, you're saying what the formula was to calculate x?
No, hang on, Lerato. You already calculated the x, and then
Yes.
I agree that x is 8. But I'm just starting from the beginning, from the theorem of Pythagoras to say, sorry, The theorem of Pythagoras is saying, according to this diagram of ours, this triangle of ours, okay, is x squared plus y squared equals to s squared. Remember, s is our hypotenuse.
Yes, sir.
So you and I agree that x squared plus y squared equals to s squared. So y squared is just y, then we square it. S is 10, then we square it. That's why I said to you, I agree with you when you say x is equals to 8. Because it's coming from this theorem of Pythagoras.
Yes, sir.
Is that how you got it? From this theorem of Pythagoras?
Yes, sir.
It was just a matter of taking y squared to the other side. So it becomes hypotenuse minus y squared. So it's 100 minus 36, which becomes 64. The square root of 64 is 8. Okay? Now, let's go back to this theorem of Pythagoras, which is x squared plus y squared equals to s squared. Okay? Please, do we agree that the derivative of x squared is 2x dx over dt? From the formula, from theorem of Pythagoras' equation.
Yes, sir.
Remember, Larado, we said x squared plus y squared equals to s squared. Now, we're just finding the derivative of this formula, of this theorem of Pythagoras. We are differentiating x squared plus y squared, which is equals to x squared with respect to t, time. So x squared, the derivative of x squared will be 2x dx over dt. Do you agree? Or no?
I agree, sir.
Plus the derivative of y squared will be 2y dy over dt. Do we agree?
Yes, sir.
Which will be equals to 2s ds over dt. Are you still with me?
Yes, sir.
Now, do you see that we have got 2x dx over dt plus 2y dy over dt equals to 2s ds over dt. Now, we can somehow divide by 2, this equation by 2. Do we agree? That doesn't make any difference.
Yes, sir.
The two will fall away from this equation. Do we agree?
Yes, sir.
So we'll be left with x dx over dt plus y dy over dt, which is equals to s ds over dt. Are you still with me?
Yes, sir.
Now, what is x? What is the value of x? Lerato, the value that you just found, the one that you calculated, what is it?
Oh, it's 8, sir.
8. So in the place of x, we will put that 8. Okay?
Okay.
It will be 8 dx over dt. Okay? It's 8 times dx over dt. Do we agree?
Yes, sir.
Plus, we know that y is 6, eh? But then we know what is dy over dt?
Oh, it's 0.
0. So then we'll have plus 0. Do we agree?
We'll
6
have?
times 6 times
Yeah, 6
0.
times 0. Yes, sir.
6 times 0 is 0. Do we agree?
Yes, sir.
Equals to, what is S?
Minus 400. Oh, no, sorry. S is 10.
10. So now we've got 10 times, what is ds over dt? dt.
Minus 400.
Minus 400. We agree, ne?
Yes, sir.
Now, on the left-hand side, we have got 8 dx over dt. On the right-hand side, then plus 0, that is just 0. Now, what is 10 times 400? But it has got a negative sign in front. What is it?
4,000.
Minus 4,000 kilometers per hour, ne? Do we agree?
So when you times, oh, it was just distance. So, sir, because it was the distance of 10 kilometers times the
ds.
rate minus 400 kilometers per hour. So when we
Yes.
times kilometers by kilometers per hour, is then the resulting unit for the answer kilometers per hour?
Kilometers per hour. Huh?
So because we times a unit that was in kilometers by a unit that was in kilometers per hour, and then you're saying our resulting answer is minus 4,000 kilometers per hour.
Okay, hang on. Distance is measured in kilometers in this case, okay? That's
Yes, sir.
kilometers. Times minus 400 kilometers per hour.
Yes, sir.
So what should be the unit of distance in this case?
Kilometers squared.
Kilometer squared. Okay. I hear you. Per hour. Do we agree?
Yes, sir.
Then, remember on the left-hand side, we have got what? 8 kilometers.
Kilometers.
Yeah, that
So
8
it's
is
going to
8.
divide out again.
We divide by 8, ne?
Yes.
We divide by that 8 kilometers.
Yes, sir.
Then what do we have on the left-hand side when we do that, when we divide?
Minus 500 kilometers.
No, right. We are dividing by this 8 on the left-hand side. We are dividing, meaning, oh, sorry, slowly. Maybe I'm confusing you. We are dividing both on the left-hand side and the right-hand side by this 8.
Yes, sir.
Then on the left-hand side, what will we be left with?
Oh, on the left-hand side, we'll be left with dx over dt.
Dx over dt. Then please go to the right-hand side and tell me what you get on the right-hand side.
Minus 500 kilometers per hour.
Thank you. That is what these people have been looking for. That kilometer, as you said, remember it was kilometers squared per hour. So that kilometer will cancel with another kilometer.
Yes, sir.
So now we'll be left with minus 500 kilometers per hour. So the horizontal speed of the plane towards the station is 500 kilometers per hour. Is it making sense or not?
Yes, sir.
Are you sure?
Yes, sir.
Okay. Now, if that is the case, can we now move on to number 2?
Yes, sir.
Okay. Is number 2 clearly visible to you?
Yes, sir.
Okay. In number 2, they are saying there is a light A light is on the ground, 20 meters from a building. A light is on the ground, 20 meters from a building. A man, 2 meters tall, walks from the light directly towards the building at 1 meter per second. How fast is the length of his shadow on the building changing when he is 14 meters from the building? Let me repeat. A light is on the ground, 20 meters from a building. A man, 2 meters tall, walks from the light directly towards the building at 1 meter per second. How fast is the length of his shadow on the building changing when he is 14 meters from the building? Please try to visualize it so that we can have a diagrammatic representation of this situation. Lorato?
Yes, sir.
Okay. I'll keep quiet, and then while you are visualizing how this situation can better be represented diagrammatically, and then once you are done with your diagram, please say so, and then we'll talk about how the diagram is looking like before we get to talking about what is it that we need, what is it that we know, and then what is it that we don't know, using the information that we have been given, how then we can be able to proceed to find what is it that they are looking for. Is that okay?
Yes, sir.
Okay. I'll keep quiet, not interrupt while you are figuring out how the diagram will look like.
Well, sir, I've drawn like 3 different diagrams.
3
And
different diagrams.
well, yes, sir, but they all like basically a different. It's like it's the same thing but drawn in 3 different ways. And I'm trying to understand. I have a lot of questions that are in my head that are circling that I'm wondering about to actually try and present the information in a way that it's helpful to helping me calculate the answer or an approach to the question. So my first diagram looks like there's a lamp, and then but I think so we actually, this was one of the questions that was in the last session that we were working through, but you said it was supposed to be given for homework. But anyway, my diagram has the light, and then I have the man standing at 2 meters tall. Then I have the distance from the lamp to the building as 20 meters. And then I have the 14 meters away from from the building to a point. But then I redrew it again, and now I have more of like a triangle. So I have a right angle triangle with the right angle in the right corner. And then I have 2 meters for the Y, because that's his height. And then his shadow would fall forward of him. So I'm thinking the horizontal distance of his shadow would be then that X value. And then the hypotenuse, I don't have any other values for the other stuff. So what I'm wondering about is we need to know how far his shadow falls away from him. And then we need to work with that to say how does that fit into calculating the shadow's movement on the building. So my one thought was, if he's standing, where he stands, just as a person, not accounting for his shadow, that's like a straight line, right? So then anything else would be his shadow. So I'm thinking maybe then I can make X 14 meters. Because if it's asking what speed is the shadow moving, how fast is the shadow moving? Sorry. Yeah, how fast the length of his shadow is moving on the building at 14 meters. That means at 14 meters, his shadow is like appearing on the building, right? So then what I'm left with then is a triangle with an X of 2 meters and a Y of 2 meters and an X of 14 meters and then a hypotenuse. But I'm not sure what to make of the 1 meter per second, which is how fast he's walking. But that's not the same as how fast his shadow is moving.
Yes. Okay. Maybe I hear you and I agree with what you are saying. Okay. Probably I need to make it easier for you. Okay. Lerato.
Yes, sir.
I'm trying to think. These are things that we are experiencing on our everyday lives, but we tend to just not to consider them or take them into consideration. Where have I seen this? Have you ever been have you ever been at the main campus in Pretoria?
No, sir.
No. But okay. I'm trying to think. Okay, from where you are sitting. These lights, okay, we've got the street lights. We've got lights in the houses. And then there are places where you'll find that there are lights maybe in the garden.
Yes, sir.
Some of the lights will be facing towards the buildings, or trying to think of, or maybe even from the garden. Let's say a light that will be facing towards a tree. No. Okay. Lerato, you have been on a freeway, yeah?
Yes, sir.
On a road. You have been on a road. And then you saw many billboard
Yes.
signs on the road.
Yes, sir.
Those billboard signs, at night, there are lights that are reflecting on those billboards, okay?
Mm-hmm.
For us to can be able to see what is it that is being advertised there. Is that not so?
Yes, sir.
Okay. Now, that one of a billboard, because it's closer. That light is reflecting, will be shining on whatever that they're advertising. I'm trying to think of another example. Example. Okay. Billboard, which other one? Trying to think. Just give me a few seconds. Just a few seconds. Billboards and which other ones? Huh. Yeah. Leonardo, yes. The light can be at the bottom. The billboard will be standing right up. The light might be on the ground, facing towards that advertisement. But I'm trying to make it simpler for you because in other cases you will just see a metal holding that light that shines on whatever that they'll be advertising. But
Yes, sir.
okay, now you and I, let's do this. From where you are sitting, outside your house, where you are staying, okay?
Mm-hmm.
Let's say from the gate, I don't even know how far your gate is. Let's say at the gate, there is a light on the ground, okay?
Mm-hmm.
But that light is shining on your front door from the gate at night. That light shines at the top of your front door.
Okay.
Is it making sense? The light at the gate is on the ground, is shining at the top of your front door. Can you see that?
Yes, sir.
Not at the bottom, but at the top.
Mm-hmm.
This is the situation that we are facing here. Now, if you and I are looking at it from that point, we say, I'm trying to break it down in a sense that it will make sense to you. A light is on the ground. Where is the ground? Is at the gate. Okay?
Yes, sir.
At night, now it is night. That light, that means it will be on. It will be on lighting the top part of your front door. That is how I can interpret it in there. And that's how I can interpret the first line to you to try to make it easier. Is it making sense?
Yes,
The
sir.
light is on the ground, is shining or is lighting the top part of your front door. Then, now, here is a man who is tall. Here is a man who is 2 meters tall, who is now entering your yard. Okay? That man is 2 meters tall, walks from the light, where? Now into your front, towards your front door. Do you get this, the situation?
Yes, sir.
It's like this person is entering your yard, but there at the gate is that light. Now this man is walking towards your front door. His height is 2 meters. A man 2 meters tall walks from the light directly towards the building at 1 meters per second. Do you see the scenario in this case?
Yes, sir.
How fast is the length of his shadow on the building changing, when he is 14 meters from the building? Can you visualize this?
Yes, sir.
Okay, now, please, let's have this diagrammatically. From that light, remember, I think, the very similar lower part triangle that we drew previously.
Yes, sir.
Remember, from the right angle triangle, we considered the lower triangle, the lower right angle triangle.
Yes, sir.
Okay, please, let's consider that triangle again. Okay.
Okay, sir.
Remember, in the previous exercise, where the plane would come to a standstill, or where the plane would stop, that was the point that was referred to as the radar station. Okay.
Yes, sir.
Now let's consider that point to be where the light is. You've got that triangle. Now, where the hypotenuse and the x-axis meet, that's where the light is. Do you follow it?
Yes, sir, but I'm confused why the light is there.
Oh, okay, I'll tell you why. You've got that triangle, We didn't talk about the y.
Yes, sir.
The hypotenuse and the x-axis on that triangle, that's where the light is. Okay.
Okay, sir.
Where there is y, what is it? The y.
It's the height of the person.
Mm-mm.
The Y, sir.
Mm-hmm.
Is it the height of the building?
Yes. That's where the building is. Remember, I've constantly been referring to the top of the front door.
Yes, sir.
So that Y refers to the building.
Okay, sir.
Is it making sense?
Yes, sir.
Now, let's talk. A light is on the ground, 20 meters from a building. Now, from the hypotenuse, where the hypotenuse and the x-axis meet, do you see that point where the light is? Which I said is where the light is.
Yes, sir.
Meaning, where the hypotenuse meets the x-axis is where the light is. Now we are moving from where the light is to the y, to the y. Y is the building. Do we agree?
Yes, sir.
Yes. If y is the building, then we have got this x-axis. Are we together?
Yes, sir.
This x-axis is what this 20 meters is the distance from the light to the building.
Okay.
Do we agree?
Yes, sir.
Is on the x-axis. So is 20. Then the next thing, this man is 2 meters tall, and he walks from the light directly towards the building at 1 meters per second. All right. You and I, in that triangle, please draw a line from the x-axis to the y-axis. You draw a line from, no. You draw a line from the x-axis to the hypotenuse. You can draw it in between.
On the x-axis. To the hypotenuse.
Yes, Lerato. Where at the, remember at the top, you see the hypotenuse. At the top of the hypotenuse is where there is, okay, slowly. We didn't mention what the hypotenuse is. We just know that there is that line that we refer to as the hypotenuse. Do we agree?
Yes.
Yes. But we know from this triangle of ours that this hypotenuse means the y-axis. Do we agree? Which
Yes.
is y, which is y. In order to form it, and then below is the x-axis. Our triangle is complete.
Yes.
On the y is y. On the hypotenuse is just that hypotenuse.
Yes.
Right. Below is this x. Do we agree?
Yes.
Are we clear?
Yes.
All right. If we are clear, now, here is my request to you. Do you see where the hypotenuse and the x-axis meet, where the light is?
Yes.
Thank you. Now, do you see where the light is and where the y is on the x-axis? Meaning you are moving from the light on the x-axis,
Yes, sir.
on this horizontal line to the building, which is the x-axis. Do you see what I mean?
Yes, sir.
My request is that in between, just draw a line. I don't know how big your right angle triangle is, but my request is that in between the light and the building on the x-axis, you will just draw a line. This line will be parallel to the y, which is the building. In between, you just draw that line to the hypotenuse, which will be parallel to the y, which is the building.
Yes, sir. Oh, so I understand what you're saying. I've drawn the line now.
You draw the line.
Yes, sir.
Now, that line is 2 meters, is the height of this man.
Okay, sir.
Do you get it?
Yes, sir.
Now, as long as you get it, now let's go to the x-axis. Focus now is on the x-axis. You drew that line, it is 2 meters, is the height of, is the man, yeah, is the height. It's 2 meters tall, is the height of this man. That line, which is parallel to the y, is the height of this man. Okay? We agree on that one, eh?
Yes, sir.
A man 2 meters tall walks from the light directly towards the building at 1 meters per second. Okay, let me not bother you with this 1 meter per second for now, okay? But allow me to go to the next line. I'll come back to this. They're saying, how fast is the length of his shadow on the building changing when he is 14 meters from the building? How fast is the length of this man's shadow on the building changing when he is 14 meters from the building? But remember, this man started to move when the light was, or yes, that we know that the light is stationary at 20 meters from the building. Do we agree?
Yes, sir.
We drew that line in between the where the hypotenuse meets the x-axis, and I requested you to draw the line from the x-axis to the hypotenuse. So now that means where you drew that line from the y to that line is 14 meters. Because they are saying, how fast is the length of his shadow on the building changing when he is 14 meters from the building? Is it making sense?
Yes, sir.
Meaning from y to that line that you drew is 14 meters.
Yes, sir.
Now, do you know that? Now, do you see that from that line to where the light is, there is a distance that we don't know there?
Yes, sir.
Okay. Now, that distance, we know that from y up to that line of 2 meters is 14. Please, from where the light is to that line of 2 meters, please write x. Meaning from the light to that line that you drew, which is parallel to the y-axis, please write x.
Okay, sir.
Now, but you and I know that from the light to the building to y, from the light to the building is 20 meters. We agree
Yes.
on that. We agree on that one. Ne?
Yes, sir.
So, can you and I somehow then agree to say from the light to that line of 2 meters where this man is standing is 6? Do we agree?
Yes, sir.
Are we in agreement on that one?
Yes, sir.
Thank you. Now, that means the diagram now is looking like this. You've got a triangle. Where y is representing the building. And then the x-axis is divided into 2. From light to that line of 2 meters, on the x-axis is x, okay? Then on the x-axis, from that 2 meters to the y or to the wall is 14. But we know that that x is equals to 6. Do we agree, you and I?
Yes, sir.
Okay. Now, if we agree, now let's go a step back to what we have been given and try to put everything together. A light is on the ground 20 meters from a building. We know that that is from where the light is up to the building. It's from where the light is to the building. We know that that entire distance on the x-axis is 20. Okay, Lorado? But now,
Yes,
in the triangle is divided into 2. We divided that triangle into 2. There is a line that is parallel to the y-axis, which is representing the height, which is 2 meters. And then on the x-axis, we have got x, which you and I are saying is 6, because we know that that man is 14 meters from the building. We know that that man, where we drew that line of 2 meters to the building is 14. Do we agree?
Yes, sir.
Okay. If we agree, and then that whole x-axis is 20. Please. Now, that is somehow, there is somehow an agreement on the first line. Now, the second line, it says, a man 2 meters tall walks from the light directly towards the building. Okay, that line that we drew his height. So this man walks from light directly towards the building at 1 meters per second. What is this 1 meters per second, Lerato? Okay. Let me put it in this way. Lerato, that theorem of Pythagoras, again, it is in use here again. All right.
Okay, sir.
In terms of the x, the y, and what do we call our hypotenuse in this case? Because yes, the horizontal is the x, but it's divided into two. Remember, another part is x, another part is 14. It's 14. Eh?
Yes, sir.
And then in this triangle, we have got this line, which is 2 meters, and then we've got another line of the wall, which we just refer to as y. Clear?
Yes, sir.
That one on the wall is just y, but this one for the man is 2 meters. Now, what is this 1 meter per second, according to you? A man 2 meters tall walks from the light directly towards the building at 1 meters per second. What is it?
It's his speed, isn't it, sir?
Yes, but in terms of x and y, as well as time, what is it?
I'd assume it's the 1 meters is his horizontal x.
Horizontal, yes, I agree. So now this is 1 meter per second. Now, do we agree that this is dx over dt, which is equals to 1 meter per second?
Yes, sir.
Are you sure?
Yeah.
Okay. Now, you and I agree that 1 meter per second is dx over d is equals to dx over dt is equals to 1 meters per second. How fast is the length? Remember, this man is standing, eh? The length of his shadow on the building changing when he's 14 meters from the building. What are they looking for? Just take a guess.
The hypotenuse?
No. The length of his shadow.
Wouldn't it also be like the value in terms of x?
Lerato, x is on the horizontal. You and I are done.
Shadow.
The shadow. The next line says, the third line, the third line says, how fast is the length? Length of what?
His shadow.
His shadow.
Sir, I'm getting reminders that I'm supposed to join another meeting now. Isn't it then the like the shadow as it grows on the wall, wouldn't it be the y then?
Yes. But now, the rate at which y is changing, that means dy by dy over dt. Do we agree on that one?
Yes, sir.
Is the length of his shadow. The length of his shadow is y. But the rate at which, how fast is the length of his shadow? How fast is the length of his shadow on the building changing? Meaning the rate at which y is changing when it's 14 meters from the building. That means dy over dt is what they are looking for. Is it making sense?
Yes, sir.
Okay. They are looking for dy over dt. You say you are joining another class?
No, sir. On Tuesdays there's a class that happens at the same time, and then I have an external class that I have to join at 7:30, and then that runs for an hour, which is usually why on a Tuesday I end up missing the last half of the class.
Okay, I hear you. Please advise me.
Because now we're getting to the part of the question that is the important part. I was gonna see if I couldn't try join just so I can be present and get the recording on the other class. And then we can finish this question in the meantime. Because I don't know if maybe the teachers might be running late. But it's now 7 past, half past, so.
That's why I'm saying, please guide me.
I'm gonna try and join, but I think in the meantime we can just finish this question, sir, because we're basically almost getting to the end of it, right?
We are almost in the middle.
Almost in the middle, not even halfway.
Remember, we still have to go back to the theorem of Pythagoras, put all this information that we have together so that we can be able to calculate what is required, which is the rate of the change of y. As you and I agree that when they say how fast is the length of his shadow, the length of his shadow, the length of the shadow can come from the x-axis. Do you agree?
Yes, sir.
Shadow. You don't see your shadow from... How do you calculate your shadow?
Well, sir, I was thinking of it in the way that, like, you would see your shadow on the ground, But if you keep, like, let's say you're far enough away from the building and your shadow's not on the wall yet, it would be on the ground. But I understand now I understand what the question was saying when it's talking about the length of the shadow on the wall, because as you get now closer to the building, then the shadow's no longer on the ground, it's creeping up the wall.
Yes.
Like you can see it on the wall.